What's up, guys? We're going to be talking about variables in coding. We can think about a variable as a location in memory, or you can think about it as a bucket that holds a certain value. And every time we access that bucket or we access that location in memory, we can retrieve the value that's stored in that bucket. So a simple example is, let's define a variable in JavaScript. And we can do so by using let. We'll call our variable x, and we'll give x the value 8. And in JavaScript, we like to end our line with a semicolon. Now, the interesting thing about JavaScript is it doesn't care that much whether you use a semicolon or not. If you are from a background where you're used to writing PHP, for example, and PHP requires the semicolon, otherwise it will error out, then you might feel more comfortable leaving the semicolon in JavaScript. Whereas if you come from another language like Python, which doesn't make use of semicolons to indicate the end of a line, you might prefer to write your JavaScript without semicolons. There's generally a lot of debate among developers whether you should use a semicolon or not. Ultimately, it doesn't matter too much. We're going to be making use of the semicolon because it helps to indicate the end of the line. Now, if we execute that script, it's not going to do anything at the moment. In fact, let's save it. It's still executing hello world. If we run that script, we get nothing in the output. And that's because we haven't explicitly printed anything to the screen. So if now we make use of our console log command and we'll pass in the value of x, so we're basically saying to JavaScript, please print the value of that variable x to the screen. So let's execute this. And we see the number 8 printed to the screen. Now, once we've declared our variable, we can reassign it as many times as we like. For example, if we set x equals 9 on the line below it, and then execute that script, we'll see we now get 9 printed to the screen. So what we can see here is that the JavaScript executes in order, line by line. So for example, if we move this x equals 9 to after the console log and then execute the code here, notice we get 8 printed to the screen. That's because at the time of using console log, the value of x was 8, and we reassign x to 9 after that console log. So if we then call console log again and pass in the value of x and then run this, you can see we get 8 printed to the screen, and then we get 9 printed to the screen after the variable is reassigned. Now, you might wonder, why did we use let x equals 8 the first time, but the second time when we reassigned the variable x, we just wrote x equals 9? Well, before we can assign a variable, we have to declare that variable. What we're actually doing here is declaring and assigning the variable at the same time. But we could do something like this, let x, then we could say x equals 8. So we've separated the declaration of the variable and the assignment of the variable. So this will work just fine. Now, depending on how we have our JavaScript configured, if we just go in and use something like x equals 8 without first declaring the variable. So we've assigned x, but we haven't declared x. This will actually produce some errors. Now, it might work okay in this setup. You can see this code does actually run, but you'll see in many contexts, this code may not run and it might produce an error because we're using a variable that we haven't declared. So the first step is declaring the variable. The second step is assigning the variable. We just merge that into one line of code with let x equals 8. Now, virtually all programming languages make use of variables. They also make use of different types of variables. And one of the types of variables is referred to as a constant. So instead of let x equals 8, in JavaScript, we can use const x equals 8. Constants are very similar to variables, apart from they can't be reassigned because their value is constant. That's why they're referred to as constants. So let's take a look at this code. We are declaring a constant x. We are assigning it the value 8. We console log that to the screen. Then we attempt to reassign x. Now, the JavaScript is not going to like that because a constant should not be reassigned. It's meant to be constant. So let's see what happens when we run this code. So you can see here we actually get an error message, and it's pointing out that the error is happening here on this line where we've written x equals 9. And it tells us that that's line 4. And notice it says type error assignment to constant variable. So this error message is telling us you can't set x equal to 9 because x is a constant and you've already set its value to 8. Now, so far, we have just set variables to numbers, which is a type of data. A number is a type of data. But there are other types of data that we can store in variables. So an example of another type of data is a string. And a string is indicated by single or double quotes. So let's create a string and assign it to x. This is a string, and we're going to continue by ending with a semicolon. And once again, we are going to console log the value of x to the screen. Let's run this. So we get output, this is a string. And notice it doesn't matter whether we use single or double quotes. Both of these are valid. So if I save the string in double quotes and rerun the script, we get the same string output to the screen. Another type of data that can be stored in a variable is what's known as a Boolean. And a Boolean is simply a true or false value. It doesn't need to be placed inside quotes. So we put here let x equals true. Let's run the script, and we're console logging true to the screen. And on the flip side, we can also set a Boolean to be false. If we run that, we get false echoed to the screen. Now we can use the JavaScript type of operator in order for JavaScript to tell us what type of data is stored in a variable. So we're now going to console log type of x to the screen. Let's run that code. And you can see we get the value Boolean echoed to the screen. Now, how did JavaScript know that was a Boolean? JavaScript intelligently figures out the type of data that's stored inside a variable. Now, this is not true of all languages. So in some coding languages, when we declare and assign a variable, we need to specifically state what type of data is going to be placed inside that variable. So example would include a language like C++. It also includes a language which is built on top of JavaScript, which is known as TypeScript. So in these languages, we can't necessarily just create a variable with a value. We need to create a variable with a value, but we also need to specify what type of data is being stored in that variable. You can see that JavaScript figures this out for us automatically. So if I pass a string and we rerun the script, you can see that JavaScript identifies this as a string. Now there are other types of data, and we'll look at these a bit later in the course. Examples include an object, an array, a function. All of these are different types of data that can be stored in a variable. Now, the reason why types of data is important is because it allows us to understand what we can do with that variable. So as a simple example, let's assign numbers to the variable x, and let's create a new variable. Let's call it y, and let's assign another number to the variable y. And we're going to console log a mathematical operation. And this is something that is, again, supported by pretty much every programming language, the ability to perform math operations on variables. So we are going to console log x plus y. So let's save and let's run this. So we get the value 15. So JavaScript has recognized that both x and y are numbers, and it's added them together. What if instead of numbers, we had two strings? So we'll say hello and world. So x is the string hello, y is the string world. We are going to console log x plus y. So what happens when we ask JavaScript to add strings together? Let's see what happens. It concatenates them. Now, of course, we would ideally have a space between hello and world, so let's just add that. Now, concatenate is something that is specific to strings. In this case, JavaScript has figured out that X and Y are both strings, and it concatenates them, which basically means to take two smaller strings and make a larger string. Now, JavaScript figures this automatically, but it's not going to be the case with all languages. So if we take something like PHP, for example, we can't just add two strings together. Just to give you a little taste of what this might look like in PHP. So in PHP, we declare a variable using the $sign. So we'll say $x equals hello. We end with a semicolon, very similar to JavaScript. And we can say $y equals world. And in PHP, we don't use console log, we use echo. And let's see what happens if we try and echo the X variable plus the Y variable. Let's run that code. We get PHP fatal error. Unsupported operand types string plus string. So in PHP, this plus is specifically for adding numbers. So if we were to use 5 and 10, like we did in the JavaScript, then PHP is going to be okay with that. It associates this plus with being a mathematical operation. So when we run this code, we just get 15 echoed to the screen, no problem. But when we try and add strings together, it says, well, you can't add a string. That doesn't make any sense. So we can see how JavaScript and PHP can achieve the same thing, but they're slightly different. Just to return to our string example, how would we get this to work in PHP? Well, we have to use a different operator. We can't use plus because that is for maths in PHP, but we can use the concatenate operator, which is simply a dot in PHP. So let's run this script, and you can see we get hello world, because when we're dealing with strings, we have to use this concatenation operator rather than the addition operator. So back now to our JavaScript, let's see if we can deliberately confuse JavaScript. So we're going to say X equals a string, hello, and then we're going to say Y equals 5. So we're seeing if we can get JavaScript to add a string and a number. Take a moment and think about this. What do you think is going to happen? Are we going to get an error? Are we going to get something else? Let's find out what happens. Let's run this code. We get hello 5. So what's just happened here? Well, JavaScript looked at this and decided, seeing as X is a string, then 5 must also be a string. So we can see that JavaScript intelligently tries to figure out what we're looking to achieve by changing the type of data on the fly. This is not necessarily something that will occur with all languages. This is something that's specific to JavaScript and possibly some other languages, but other languages won't be that happy if we try and add an integer with a string. One thing that most languages allow is for us to try and change the type of a piece of data. So as an example, let's imagine that we try and add 5 as a string to 5 as a number. And JavaScript's going to behave in much the same way here. If we try and run this, we get 5, which is a string. And in fact, let's assign that to a third variable. So we'll say let z equal x plus y. Then let's console log type of z. And what we should see here is that z is in fact a string. Now, as we mentioned, we can ask JavaScript to set a specific data type. So what we'll do is we'll call a parseInt function. We'll talk more about functions later in the course, but essentially a function is something that does something to a piece of data. So this is the parseInt function. And what parseInt does is it takes a value, and where possible, it's going to convert that value into a number. JavaScript has the ability to look at this string with the number 5 and convert that into a number. So let's see what happens when we run this script. So now we get type of z equals number. And if we just console log z, what do you think we're going to get in this case? Well, now we get 10 because x has been converted to the number 5. Y is also a number. So now z is going to be x plus y, which is 10 in this case. So we've now console logged 10 to the output. Now let's just have a look at a few more of these math operators. So we're going to set x to 15. Both of them are clearly numbers in this case. I'm going to say let z equals x divided by y. So in terms of writing code, division is always a /. So let's run this. We get 15 divided by 5, which equals 3. For multiplication, we use an asterisk sign. We don't use an x. Hopefully you can see why that would be a problem, because we'd have x, x, y. In fact, x is used for our variable here, so it can't be used for multiplication as well. So when writing code, that asterisk is the multiplication sign. So let's run this code. We get 15 multiplied by 5, which is 75 according to the output. What happens if we run x multiplied by y plus 5? Now, if we think about this, depending on the order of things, there could be more than one answer. Because if we do x multiplied by y, we get 50. And then if we add 5, we get 55. But if we add the 5 to y first, we've got 10. We've got 10 times by 10 equals 100. The question is, which is correct? Is the correct answer 100 or is it 55? Well, let's see what JavaScript thinks. JavaScript says the answer is 55. Certain mathematical operations take precedent. So for example, multiplication is more important than addition. So JavaScript evaluates this first, multiplies 10 by 5, and we end up with 55 as a result. Now, rather than getting bogged down trying to remember the order of different operations, the easiest thing to do is to just make use of brackets. So for example, if we put brackets round x multiplied by y, then whatever is in brackets will be dealt with first. So we know that x will be first multiplied by y to get 50, add 5, 55. That's the same as what's happening by default anyway. So technically we don't need those brackets, but if it makes it clearer in our mind, there's no harm in using these brackets. Besides, perhaps we want something different. Perhaps we want y plus 5 to be run first. So this is now going to change the output of the script, because firstly, y is added to 5 to give us 10. Then afterwards, it will be multiplied by x. So if we run this, we now get 100. We can see a completely different output of this script because we've moved the brackets around. It changes the order of operations. This is something that's going to be true in pretty much every programming language that you write. You could make use of brackets to change the order of these operations. Now, another thing that we can do is check to see whether certain values are larger than other values. So we can say let z equals x larger than y. Now let's just see what happens if we console log the value. So you can see we get a Boolean. And if we want, we can confirm it's a Boolean because we can use type of z. In fact, we need to console log it, right? Console.log type of z. So we can see we get Boolean as the type of that value. And if we reverse the sign, so this means greater than, but if we say is x less than y, well, we know x is not less than y, so we get false back, which is again a Boolean value. So hopefully that was a pretty good introduction to variables. Key takeaways are variables, it's like a bucket that stores a value and we can retrieve that value from the bucket. Alternatively, you can think about a location in computer memory that stores a value if you prefer. We've also seen that variables can hold different types of data. So they can hold strings, they can hold numbers, they can hold Booleans. They can also hold other types of data, which we'll look at a bit later, such as objects and functions. We've also discussed how some languages automatically figure out the type of data being stored, whereas other languages don't do that by default. And it's down to us as the programmer to let the programming language know what type of data we are storing in the variable. Finally, we've seen there are different types of variables. For example, one common type of variable is known as a constant. And unlike regular variables that could be reassigned, a constant, once it's given a value, it's going to keep that value and it can't be changed.